What we're going to have here is it's going to be basically a lightning bit of the roadmap. I will be kicking things off and be handing it off in rapid succession as we go through things. My name is Stu Miniman. I'm a senior director at Red Hat. I will echo what Corinna said. This is one of my favorite events of the year. I've been going for KubeCon since the pretty early days. Actually, many of you might even remember the OpenStack days. It was kind of the seeds of some of this community and gone for a long time. I've been with Red Hat 3.5 years and love to be able to come to talk to this community, and especially thank you to all the users that share their stories. It's one of the things that brought me to Red Hat is to hear those stories. We're celebrating at this show at the CNCF. It's really been 10 years of Kubernetes. And there's some people that are like, okay, I'm in here and I'm doing well. And there's other people that are like, oh my gosh, I'm still so early in my journey. Where do I go? So this is a quote that we love from comments here. No matter where you started, really, you can get ramped up pretty quick. This community is very welcoming. There's lots of ways to get started, and the note here, I came to Commons, I didn't know a lot, took some notes, and now we've got 100 people on our development team that are building things. So it sometimes seems a really daunting task of what's in front of you, but you can get there pretty quickly. So let's jump in and talk a little bit about the road ahead. So I think we're going to cover all 186 projects in the CNCF, in 40 minutes, right, everybody? Look, we know that this is a complicated space. I had my friend and colleague Brian Gracely help me put together their slides, and he always likes to do an analogy of the city that we're in. So when we think about Paris, and we think about what we're doing in this cloud-native ecosystem, really it starts with we want to have a really great experience. Just like the wonderful restaurants and patisseries and cafes here, there's so many things to choose from, but when I go to a place, I don't want to think about all of that complexity. I want them to be able to abstract that away from me. So that's that experience that I want to think of, and that's, here we have an abstract picture of Paris itself. So, that experience, and I want to take advantage of it, but I don't want to have to learn all of the details underneath it. Why do you come to Commons? There's so much going on. We appreciate you coming, 1.5 kilometers away from the convention center, because there are a lot of day zero pieces, and we've got the highlights for you here. So just like the Eiffel Tower and Notre Dame and Sacré-Cœur, here we're going to talk about Kubernetes. We're going to talk about scalability. We'll talk about the latest of how to modernize virtualization. What we've built with OpenShift is a trusted, comprehensive, and consistent platform that can give you the experience regardless of where you are. If you're starting in a public cloud, if you're starting in the data center, when we talk about AI, a lot of times we're pushing out to the edge for inferencing. Of course, Kubernetes helps give you some of that same experience regardless of where you go across the various environments. But not only kind of the basic building blocks, but as we show here, we want to look out to the horizon and talk a little bit about the future. So of course, we're going to talk a bit about artificial intelligence. AI is all the buzz, but in this community, and one of the other really hot topics has been platform engineering. So that's something that we'll spend quite a bit talking about in some of the sessions that we're doing here, and always open to those new pieces. I feel every time I come to this show, there's usually some new project I want to hear about. Oh, there's wonderful stuff happening in sustainability. For those of us coming from North America, we oftentimes look to the Europeans to help give some of the regulations that help drive things throughout the rest of the globe. So sustainability and some of the energy efficiencies that we're seeing in the community for containers. There's a regulation here starting in the EU. So again, looking out to the future, there's always lots of new technologies to learn, and definitely take advantage of all of those things where you look at it. When we look back, I said it's been 10 years of Kubernetes. We started OpenShift even before Kubernetes existed. When we started OpenShift, we really had no idea where it would go. It's due to the creativity of our customers and the community that we've had the success of where we are. So everything from retail and financial services to manufacturing and government companies, that they've taken the creativity of these communities and driven them into real use cases for thousands of environments in every industry all across the globe. And as I mentioned, the platform is trusted, it is comprehensive, and it's consistent. except when you go from Google Slides to PowerPoint, it looks like we lose a little bit on the spacing. You know, unfortunately, you know, we look at those things. But yeah, OpenShift there. And look, you know, the little bit of the product, you know, don't just take our words or all the customers here. We have independent validation. This came out in Q4 last year. The Forrester Wave for a multi-cloud platform. And we were really proud of this one because it said that we really helped set the pace of capabilities for this market. And of course, everything that we put into OpenShift starts here with this community, and it's all open source. So, you know, really exciting that we had there. And finally, just if we look from a product standpoint, we spent many years having that solid, trusted foundation of what we've done with OpenShift. And really over the last year or so, when we look at some of the expansions of what's happening in the application modernization space, developer services and platform engineering that we talked about, and of course AI. So look for those, lots of ways that we can expand our technology. We're going to go through in a lot more depth now some of the other pieces of the stack that we're doing, and thanks again for joining us.
Thanks, Stu. So my name is Stevan LeMeur. I'm a product manager working on developer tools. I'm primarily focusing on Podman desktop. So before we speak about developers, who in the audience is a developer or a platform engineer? Quite a bit. Cool. So power to the developers. So at Red Hat, our mission is really to empower the developers to build better software, faster, and more securely. And in fact, when we look at developers, we also look at the different challenges that the organizations are facing. There's a first bucket of challenges, which is coming from application modernization, where 80% of the organization believes that they will have to modernize half of their legacy application in the next 2 years. There's this rise of generative AI as well. It's impossible to avoid it and to miss it. And Gartner predicts that 80% of the enterprise will have AI-infused application deployed by 2026, if it's not earlier. Developer productivity is still a struggle. All these technologies layers are adding a bunch of challenges, and it increases the cognitive load for adopting the technology. So it's also a source of low productivity. And in this context, Gartner predicts that 75% of the companies will establish platform teams to help the application delivery. And on the other side, there's security. That is a big concern today. And it's not really a matter of when there will be an attack. It's more it's not really a matter of if there will be an attack on the security, but it's more a matter of when. So for that, how we are looking at this from our angle is that we are looking at two main personas: the developers who are writing code, writing the applications, and then the platform engineers, the developers, the one who are creating the tools and the solutions that help the developers to be more productive and have pleasant experiences with the different tools and the different solutions in place in the organizations. So what we do is that we enable the development teams to deliver business value faster. So for that, we have created an integrated self-serve developer experience from end-to-end with Red Hat Developer Hub. And we also extend OpenShift experiences to the developer desktop. And for this, we have containers and Kubernetes on the desktop with Podman Desktop and OpenShift Local. We also have a set of tools that you can install inside of IDEs, VS Code, IntelliJ, and others. And we also have OpenShift Dev Spaces, which is cloud-based developer environment that you can get on-premise on OpenShift. And for security, it's all about reducing the risk across the software development lifecycle. And for this, we have Red Hat Trust Software Supply Chain. So digging a little bit deeper, Podman Desktop. So Podman Desktop, how many of you have been hearing about it? Nice, that's good. So it's really about containers and Kubernetes for the application developers. It's a desktop application that runs on Windows, Mac, and Linux. It provides a container engine with Podman. Podman also has the ability to run Kubernetes objects locally, so that makes it easier to do the transition from containers to pods and then to Kubernetes and OpenShift. You can also spin up OpenShift environment locally with OpenShift Local directly from Podman Desktop. So really the goal is to simplify this experience for the developers to bring the containers on the platform. And I'm pretty sure that a few of you have been experiencing some challenges when you have your application that is containerized, that is running locally, and you want to bring it onto OpenShift. So there's a set of prerequisites for the applications, and we want to bring those prerequisites sooner in the development life cycles so that the developer can more easily transition their application to the production environment with more predictability. Developer Hub. So Developer Hub is the productized version of Backstage. So it's really a single pane of glass providing software catalogs for the developer teams. It's self-service and it simplifies the onboarding. With Developer Hub, the benefit is that it's integrated with OpenShift, so you directly can integrate with pipelines and GitOps plugins to accelerate your teams. It is supported and it's enterprise ready, so it is coming with Airbag to simplify the rollout and the adoption of Backstage within an organization. And Red Hat Trust Supply Chain. So basically, all the expertise of productizing open source projects, supporting them, securing them from Red Hat in the last 30 years. We are trying to bring this into your hands so that you can have that in your own organization by shifting left the security practices. It's really pre-integrated security guardrails with artifact signatures, attestation, and SBOM that you can leverage during the entire development lifecycle. And it's coming with a front-end experience within Developer Hub. And we are trying to bring all of this together, so understanding the development and platform engineer teams to enable the developers to write code on their desktop at scale, thanks to the effort of the platform engineering team. So this is how it looks today inside of Developer Hub, where you have Golden Pass template, which simplifies the onboarding and starting new applications. And when you start this, you will automatically have the security guardrails in place so that it will create the different tasks and the different activities of your pipelines using all the different solutions coming with that Trust Supply Chain. So the road ahead for us is really about those 4 buckets of challenges. The first one is about the modernization, so continuing to help you modernize your application. There is also how can we help the developers to create AI-infused applications, and of course looking at all the different challenges that are related to the productivity and to the cognitive load. So how can we make the technology more easier to consume by the developers, and this security, which is very important as well. And with this, I am handing over to Adel. Thank you.
Thank you. Thank you, Stefan. Okay, welcome everyone. I hope you enjoyed the music that was playing around. You know, we hear a lot about AI, and we don't hear a lot about the intelligence of things that help make AI run and scale, right? So I'm gonna just go with you in a nutshell and walk through some of the innovations that we're working on. State of the art. So just to give you an idea of the numbers, I have here on the right, or your left it depends, a couple of surveys and reports, but just to give you an idea about the data that this is coming from, one of the surveys had 700 plus decision makers, 10 plus industries, and a revenue of 10 billion plus. No surprise, I'm not going to talk about the numbers, but no surprise, there is growing demand for AI, and that has boomed after the release of ChatGPT and the buzz of generative AI. Decision maker had already opted and wanted to adopt AI, but with Gen AI, it's growing like crazy. So decision makers want to adopt AI. They want to do it responsibly. So Stu talked about sustainability. There's a lot of calculators out there, especially with machine learning models, and GPU running and so on. Have a look at one of those calculators and make sure that you're aware of the numbers. So we want to do, they want to grow, but they want to grow responsibly, and they want to do it on the hybrid cloud. They like the optionality. They like no vendor lock-in. They like to be on-prem, at the edge, or on the cloud for sure. However, there's a lot of projects either fail completely to go to production or take a long time to go to production because there's usually skill gaps. You typically don't have the skill to develop a foundational model in-house, or you are not yet aware of the infrastructure intricacies and complexities to deploy your models to production, or there is regulatory uncertainties. We've heard about the AI Act in the EU, so people are still trying to understand what that means and try to build compliance and regulations based on that. So there's a lot of complexities involved. These projects don't go to production as easily, and so we're going to talk about the pains in more details. So this is more like an abstracted away slide. In a simple environment with one or two data scientists developing models on their laptops, everything is great. I have my CPU is king in that environment, no GPUs. I can run my classification regression algorithm. I can crunch the data, clean it up, all good, all happy. But what happens if the data is bigger? What happens if the model is bigger? There's no easy way to ingest and clean the data. There's no easy way to deploy this data to production. I don't even know as a data scientist what infrastructure is, how to deploy it. I have to look for the fancy infrastructure guys to help me do that. So there's a lot of complexity in this space. And if I do it, and if I manage to do it, if my team grows to 10 people and I still do it ad hocly, I'm going to do it in my team, and then the other team is going to do it in their team, so silos form. Welcome to Shadow ITs, and things are fun. And then once, if a data scientist finishes and manages to get the model out to the platform engineers, to typically throw it out the wall, a platform engineer does not understand modeling, does not understand data science. How do they deploy all these things to production? And here goes the cycle. In addition, there is, the question of how to scale what's in production, how to improve its performance, how to make it sustainable, how to make it secure, especially at runtime or during the serving phase. All of these, chasm data scientists, they fall in between, they can't cross the line, and it's a sad story. So we bring some relievers to you, luckily. So along the stack, whether it's the data engineer, the ingestion, with AMQ streams or application data science, application foundation, or the partnerships that we have, or the Jupyter environments that we bring to you as images, as Docker images in your environment, so that as a data scientist, you're building the model with all the dependencies in place for you. And you have the environment that you need. And on top of that, what we're doing for data scientists and data engineers, so we're building a tuning and training stack. So you don't have to know infrastructure if you don't need to. Of course, it's good if you know it. You don't have to know it. So IBM and Red Hat collaboratively developed Cloudflare, which is an SDK that allows you to say, hey, I want to cluster this compute, get me this compute up and running, I want to train my models. And of course, this cycle is not just for traditional ML. I mean, this gets especially hard for large model or large language models in the Gen AI space. Also for the tuning and serving, once the developer does this, there is a lot of abstraction in place. The multi-cluster application dispatcher also makes sure that it talks to things like Ray and Torch to make sure that there is space in the infrastructure, that it can you gang schedules. You don't have to run a job if the infrastructure is not ready for it. And if there's no GPUs on any cloud provider, there is a smart scheduler that understands, oh, you know what, I'm going to wait and see, and I'm going to get you the GPU on this provider and this provider. And that's what InstaScale also is. And on the, once the model is done, once you've trained the model and stored it, the platform engineer, to solve the problem of not understanding modeling, we've also, IBM developed with Red Hat a tool called KiKit, or KKit, depends on how you pronounce it, that also helps a lot with abstracting away the runtimes for the engineers to deploy it, or the developers to deploy it. So you can go and say, have a client call and say, I want to inference using this runtime, all programmatically, and you don't have to know the intricacies of how the model works, or the hyperparameters, or all of these things. You're just here to deploy at scale. Of course, these are all based on a Cube native OpenShift projects like Kserve plus Model Mesh, which was contributed by IBM to make sure that it dynamically on and off models if they're not in use, for example. And we go down again to the same story. It's all OpenShift. It's all in the hybrid cloud. So we're using all the layered operators out there. So when you're using OpenShift, there is service mesh and serverless, which, by the way, Kserve depends on a lot to serve and to turn on and off and to scale auto-dynamically. You can do that self-managed or managed. You can do that connected or disconnected. You can do that standalone or with external control planes. By the way, for multi-cluster, hosted control planes, we bring the cheapest and fastest way to run OpenShift with multi-cluster using hosted control planes, so you have that as well. And then there is also all the traditional tooling in place. And then at the Arcos layer, we're also partnering a lot with accelerator or hardware acceleration vendors to bring those drivers in stack already in the OS. And so at the end of the day, people and decision makers want to run this on the hybrid cloud, they have it. On-prem or at the edge, they have it. So with OpenShift, this is not new. We're just capitalizing on a great platform and building our tooling on top of it. So the road ahead, I'm not going to go too much into the details, but we're continuing with partnerships with NVIDIA, Intel, with accelerator vendors. We're doing platform integration. So when people deploy machine learning application or AI application, they need a platform that is reliable enough to run that application. They need onboarding, need documentation. And Stefan talked about the developer hub. This is a great place that we're looking to integrate with more deeply in the space. Along the MLOps space, we're looking to add more along the observability and alerting line. To also for Gen AI, we're looking to have out-of-the-box support for foundation models. And for model building and development, we are looking to integrate more with, there's a lot of research going on static analysis and dependencies, especially, at Jupyter notebook level. Project Toth is a great helper in that space. So we're looking, expanding our horizon. We're working a lot and on a lot of efforts coming in. And so tune in for what's to come in AI and OpenShift. And I think there's a lot of talks here today, people who have deployed this, who know the pains and can talk more about it in the coming session. So make sure to attend. Okay, so I've talked about AI. Now we're going to talk about polymorphism. Not object-oriented programming, but just polymorphism of OpenShift. So OpenShift as a platform can help you run, you bring your needs, you bring your, I want to run this and this and this, and we give you the construct, the runtime, to actually do that for you. Some of the pains that people go through is how do I mitigate a risk of running an untested code in a shared environment? Can I manage all my application workloads from one place regardless of the runtime they need to run on? Can I expand those workloads, whether it's sandbox or not, to the cloud? How to bridge the gap between my traditional VM applications and containers? Is there an easy way to actually do migrate? So I'm running a VM, I'm hearing about the cloud native space growing. Can I make use of the benefits of cloud native while staying on my traditional VM workloads? How do I scale and run my application portably across and with low startup times, across environments and with low startup times? Again, these were the pains. We bring the relievers. So for sandbox applications or for applications that are untrusted, and you still want to run them in a shared environment or in production, you typically want to sandbox them. So if OpenShift Sandbox Containers has been around, have been GA for quite some time. If you haven't used it or don't know about it, go check it out. And Sandbox Containers uses the concept of hardware virtualization and makes itself available as a runtime. So when you're deploying a pod, you just need to say, or a workload, honestly, my workload needs to run in a sandbox environment. So it goes ahead and gets deployed on a sandbox on a virtual machine. And now it can also be deployed on a virtual machine on the cloud and not just on-prem. On-prem we had that as a constraint. Now it's not a constraint anymore. And so we have peer pods, or remote hypervisor as the upstream call it. It allows you to spin up VMs or sandboxed containers and workloads from on-prem to the cloud and burst there. Which is really an interesting project. Check it. There will be links later. And then OpenShift virtualization, helps you migrate your traditional VMs from your on-prem, from other hypervisors to OpenShift to make use of the best cloud-native principles and the Kube principles, declarative APIs, all reuse basically all the features of OpenShift like log monitoring with additional dashboards as well. And the migration toolkit for virtualization is also available to help you make the journey from the traditional hypervisor world to OpenShift. And finally, if you want to run portably, again, with additional sandboxing, with high speeds, we also have a runtime for that. CRun, in collaboration with Wasm, brings you that, so you can run Wasm workload in tech preview today on OpenShift, and you can do that all from one place. So what's the road ahead here? We're doing a lot of gross for OpenShift virtualization. So we're working on memory overcommit. We're working on overlays with secondary networking. We're working on help plugging the CPU and the networking. From a multi-cluster perspective, OpenShift virtualization does not bring you just VMs. It also brings you the ability to act as a provider. So you can use Open Virtualization as a provider with hosted control planes to deploy OpenShift clusters on top of OpenShift to reuse all of the benefits of the platform. And this has been around for some time. If you don't know about this, go check the documentation and go check the blogs. You can also now, we're looking to manage those VMs and those, think of it as a cloud. You're going to have a central place where you want to see all the metrics and the dashboards for those VMs. There's a lot of integration going on in the future with ACM, Advanced Cluster Manager, to bring you that in a single pane of glass. And then there's also going to be support with more vendors and cloud providers like Oracle. And then finally, for runtimes, I've talked about peer pods, but the applications of peer pods, start from I want to run and sandbox my CI/CD container or workload, but also I want to do that on-prem and on the cloud. So peer pods can be great for this use case. You could also previously you weren't able to run sandbox containers with hosted control plane. In the future, you'll be able to run, configure your node pool and say I want to run my control plane. My sandbox containers using HyperShift and hosted control planes with OpenShift. And then we're working on getting more use cases with peer pods, whether it's secure supply chain or running sandbox containers with peer pods for GPU workloads. So I mentioned at the beginning, security and privacy is important. At rest, everything is good. At runtime, this is where the problem is, especially with GenAI. You're getting queries in, and you don't want someone to be peeking into your memory and figuring out what, especially at the cloud. So you want to make sure there's memory encryption, there's confidential containers to help you as a project and product to help you get run your AI models safely and securely. And finally, there will be more on WASM and CRUN and other cool runtimes to hear from. With that, I'm going to hand over to my colleague, Daniel, who will walk you through more cool stuff.
Thank you. Thank you, Adel. Before we jump into the next section of the road ahead, I want to briefly remind you of this little small reminder. Because this is roadmap information, and of course, if I could see into the future, I would not be standing here, I would be probably sitting on some nice beaches. So don't buy any stock options because Adel or Daniel said Red Hat is going to do this or that next year. Because, hey, it's an open source company, and we are also dependent on the open source project, and sometimes, just because we think it is a good idea, might not turn out that it's in a community working. So it might take longer, because we need to argue, we need to discuss, we need to find out what is the best implementation approach for a certain idea. So that is, roadmap information as usual might change anytime, any notice. If you're really interested, I can only strongly suggest find the product manager, find your Red Hatter to talk to, state your needs, and then we can talk and figure a way out forward. The second thing I have to say is, obviously I'm not Harriet. If you have seen Harriet on the agenda, Harriet is product management for GitOps, actually, for OpenShift GitOps, but she realized a little bit too late that she has to do ArgoCon, which is in parallel over at the KubeCon pre-session. So that's why I stood in, and my name is Daniel Froehlich. I'm the product manager for OpenShift Edge-related products, which means, for example, single-node OpenShift when deployed to the edge, but also most prominently MicroShift, which is our smallest Kubernetes distribution, targeting small form factor edge deployments. So I'm not talking about edge, because I'm just the understudy to Harriet. So I'm talking about securing workflows and applications, because all of that technology is great and good, but we all realize that we have to take care of security. Nobody wants to see their production systems down because of some ransomware attacks. So I skipped briefly due to time over the statistics because we all know that security is hard, and it moves down and slows down your development teams. For example, last year when we onboarded the MicroShift development team to our secure pipeline technologies, we had to do static application scanning and testing. So tools in the pipeline which scan for bad practices, vulnerabilities, and the initial run created only like 1,000 tickets we had to take care of to do some analysis. Is it a false positive? Is it a false negative? Is it really a threat we need to take care of? And yeah, that reduces your productivity. And Security is also hard because it has to be continuous and holistic, and our approach is really to shift it left, to do as much as early as possible in the cycle. That is, for example, why OpenShift per default is highly secure, even if you use it as a development environment. We have all this pod security admission controller stuff because we think that this is the only approach to get rid of this developer says it runs on Docker on my laptop, but it runs not in your production chain in the cloud. So you have to do this as early, as often, and as holistically over the process, but also across the whole stack. And that brings us across the whole stack about really interesting technology. Adel already introduced already a little bit. So what we kind of did, if you look into security, securing your workload, it's kind of three different problems. First, you want to protect the workload from the workload. So if you have two virtual machines, two containers running, isolate them from each other. That's kind of checked off, done. We have crun for that. We have namespaces, SE Linux, stuff like this. The second part is you want to protect the host from the workload. Especially in the cloud, you don't want to have your malicious workload attack the host and from there attack other hosts. That is what we have with Kata containers, introducing a hypervisor, creating even more isolation around it, which is part of OpenShift sandbox containers. So that is already there, right? So what we are currently working on is on the next level of problem, which is really, really hard. That is protect the workload from the host. And for that you actually need, as I mentioned, the full stack. You need hardware enablement. So you need trusted execution environments, which really boil down to in your CPU, there's technology like Intel SGX, AMD SEV, stuff like this. Which helps you to protect the workload, for example, by encrypting the memory, by validating and attestating the surrounding and the workload that you put in private keys into your sandbox containers only when you are sure, yes, this environment has not been tampered with. So we call this confidential containers, or CoCo. Which is currently tech preview on Azure, and of course the plan is to extend this to more and more platforms. For me, as a PM OpenShift Edge, I'm especially interested in getting this technology to edge computing, because that is where it's really interesting, because your device at the edge location might have been tampered with. So, and still you have a private key on that to access, for example, some backend services. So that's crucial. Okay, I have to hurry up a little bit. So that was, for example, now the stack really from the hardware through the runtime up to the workload. And all of this needs to be integrated, what we call the trusted software supply chain, which we announced last year, where you have different components in. We have the trusted application pipeline, we heard already a lot about that. But it's more, it's, for example, also the trusted content. So that you get attestation of the content, everything is signed and validated, that it's only from trusted sources, but also that you have monitoring runtime capabilities, because software over time rottens, so you need to take care of that. And trusted application, trusted software supply chain, we are currently in the process of drinking our own champagne, meaning we onboard our own projects onto this to stabilize it and really make it smooth and round. And once we have that, we will offer this as a software as a service offering for customers to manage. And most of the internal components you can also use on-prem, of course. Monitoring and policy management. So with advanced cluster security, we are going to simplify the GitOps approach to manage RCS policies, so that you can have a GitOps approach to define your policies. But also, for example, we are on a trajectory to expand the compliance experience, to make it easier to review reports, initiate remediation, stuff like this. But also we have this, the integration with ACM continues, so we are on a trajectory and planning to improve the observability of your fleet, that you really have one single place where you can monitor the metrics, the logs, but also the security findings and reports you get from that. And also, especially for me as an Edge PM, what is really important is we are also on a trajectory to help with the scalability of advanced cluster management, that we are introducing the hub of hubs, so that you can really manage thousands of clusters, because if you have just one central infrastructure, that does not scale very well, so you need additional parameter layers around this. And last not least, I have to talk a little bit about MicroShift, and here the idea is really the combination of ACM and MicroShift. We are going to simplify the onboarding of edge devices you see on the bottom here, using something which is called FDO, the FIDO Secure Device Onboarding Standard. And that we have that capability already today, but we are going to integrate it with ACM. So that all the infrastructure you need, like for example this onboarding server, that you can run this on ACM also. And with that, I'm kind of done. This was kind of a summary of a 60-minute call, What's Next in OpenShift, which is live streamed on YouTube, so you can watch the recording. There's plenty of slides out there. I can only suggest and recommend, look at the slides, watch the recordings. If you have questions on detailed topics, on each slide there is the responsible product manager is stated on that. And simply reach out to them. They love talking to customers, understand your requirements, questions. That is really a good way. And then of course, if you have questions, reach out to the common Slack channel, where most of us hang out and are reachable, so that's another way to stay in contact. Okay, and with that, yeah, I think I can over the breakout sessions. You can, if you're interested in more on Edge, I have to promote my sessions. Come to my Edge breakout session with Henri. And with that, I think we have the next keynote up and, yeah, thank you.